Welcome back. Lance from Motive Power with episode 16 in our series on off-highway vehicle design. Today we consider what happens when the sky falls, or a big piece of rock, or the vehicle rolls over. We're going to talk about ROPS and FOPS. So ROPS and FOPS sort of rolls off the tongue. It stands for Rollover Protection System, that's ROPS, and Falling Object Protection System, that's FOPS. And along the way there's also been things like OPS, which was Occupant Protection System. But really we're going to focus on ROPS and FOPS today. So they're the two main terms to be aware of, but there's another term I'll use a bit today, and that is habitable. That's essentially the area of space that the operator inhabits. Think of it as a certain amount of volume above the operator's seat. The whole idea is that in a ROPS or a FOPS event, the ROPS and FOPS system itself, the structure, will not deform sufficiently to enter that habitable. So if you're sitting in the seat and you stay in the seat, the structure can deform around you, but it doesn't come onto you and crush you. That's the habitable. All of these designs are based on energy absorption. Yes, there's an element of strength in there. They have to be strong enough to withstand the required loads. But conversely, they have to be flexible enough to deform and absorb the energy. If you have a falling object, there's a lot of energy, particularly if it's a big rock. I once had to design a ROPS for a 1-ton rock falling 60 meters. And the client wanted no damage, not even a paint scratch. That wasn't quite achievable. The structure itself can be a separate standalone structure. It can be attached to a cabin, or it can be built into a cabin. All depends where you're coming from. We can have a look at a few examples. Here's a simple one, an additional structure on a small tractor. It's obviously just a ROPS structure, which is the main risk with agricultural tractors, that they roll over sideways. It's unusual for an ag tractor to need a FOPS because they just don't work near suspended loads. Here's an add-on for a truck. This would be typical in Australian open cut mines. It's even labelled as a ROPS. So this would have been tested on the chassis for this truck so that the whole system is tested. It's not just the bit of structure, it's what it's attached to. But this is a ROPS for this cabin. Notice it doesn't cover the cabin, so it's not a FOPS. Here's a loader where the probably ROPS and FOPS combined is an additional structure. This is probably an aftermarket piece of gear being fitted to the tractor when the cabin wasn't sufficiently protected. And here's a typical example of a tractor with a ROPS and a ROPS cage enclosed. I doubt it's FOPS because it looks like a plastic roof. So there are a variety of types, and you can combine ROPS and FOPS together. You can just do a FOPS, you can just do a ROPS. It's application specific. So once again, you need to understand the true application, what your vehicle will be doing, and perhaps more, what are the surrounds. That falling 1-ton rock I mentioned earlier was the application was to operate at the base of a high wall. Now a high wall is essentially the edge of an open cut mine, in that case 60 metres high. And they were worried about rocks rolling off the top, off the natural surface into the pit. There are standards available. Here's one. It's an ISO standard for rollover testing. And next to it is an ISO standard for FOPS. In addition, SAE and OSHA have standards. You're going to have to pick the standard that is applicable for your application in the geographic region it's going to operate. What might be accepted the most? As an Australian, if I was building something for the US, I'd probably be looking at OSHA and SAE. If I was building something for the rest of the world, it would probably be the ISO standard. So what do those standards say? Well, they have different levels that must be achieved based upon essentially the GVM of the vehicle. Bigger the vehicle, the tougher the standards, the more energy has to be absorbed. If you imagine a fully laden haul truck, well, it's a damn sight heavier than a small excavator, so the requirements are slightly different. Still based on the same approach. If you're doing the sort of off-highway vehicles that I've done in my working life, you may well have difficulty selecting a standard. If it's not a common type of vehicle, if it's not a loader or a grader or an excavator, it may not fit within the standards that are readily available to you. You may have to be inventive, pick a bit out of different standards, or select the standard that's the closest to your application, and be ready to justify why you picked that standard. Now, I said earlier, it is a strength requirement. Obviously, if you roll a vehicle over or have something drop on it, there's a big force going to be exerted, and the structure you're talking about needs to be able to resist that force. But we're also playing with potentially large energies. And that energy has to go somewhere. It can't just magically disappear. If the unstoppable object meets an immovable object, things just don't stop. The energy goes somewhere. And that's going to be primarily into your structure. It may mean that the moving object, if it's a rock, for example, will shatter, but you have to design for the energy to go into the structure. Now, energy is the same as work. Work is force times a distance. So for a structure to absorb the energy, it needs to move a distance under a load. Force times distance is the energy. So you're happily sitting here in your little habatical side yaw loader, and it gets hit. That structure has got to move sufficiently to absorb the energy, to withstand the forces, but to absorb the energy. In other words, it's got to yield, but not completely deform and crush you. So all of this relies on the operator being in the operator's position. And that's why seat belts are important for ROPS and FOPS, particularly for ROPS. No matter how good the ROPS is, it won't do the operator any good if they are thrown out on the first revolution of the vehicle. operator needs to have seatbelt on. And if you're fitting a ROPS, you need to make sure there is a seatbelt with the instruction to use it. Typically, ROPS involves applying forces at the top of the structure, laterally, longitudinally, and vertically. And there are requirements in the standards for that. For a FOPS, there's a specific weight that is dropped from a nominated height to see if that FOPS can handle the energy and the hit from that. It is a relatively pointed weight too. If your structure is intended to be both ROPS and FOPS, then those tests are done sequentially. And what it means is you're testing a potentially damaged structure. So if you do a ROPS first and it's deformed, then you do the FOPS test, you're testing a damaged, deformed structure. That's okay under the standards, but it's probably also the reason that finite element analysis and other analytical techniques are not accepted as proof of a ROPS-FOPS working. You have to actually build it, mount it on its chassis, attach that chassis in a way that represents it perhaps being attached to the axles or the undercarriage, and then test it. So if you're talking about testing a ROPS-FOPS for a big vehicle, you're testing it on a big chassis as well. The test rigs for big vehicles can be quite huge. I've also seen people writing specs and nominating standards. One that stuck in my mind was a high-speed military dune buggy. And they specified the ROPS standard that was used for bulldozers. We had to go back to that military force and say, we think you've got it wrong. There's a difference when you're working with high-speed and low-speed vehicles. I'll show you. This was the so-called special operations vehicle, something the size of a Hummer, big suspensions, big load, and capable of high speed. It certainly wasn't suitable for having its ROPS side based on bulldozers. Very few bulldozers that I've ever seen would be capable of getting off the ground in normal operation, but this vehicle is. I'm going to use a simpler picture to explain it further. This is a typical off-road racing buggy, and it's actually cornering, so one wheel off the ground, you can already see it would be heading to a rollover. If you roll over a bulldozer, it's probably because you're on a side slope and the ground collapses and you're just going to go plop. You might do a revolution, but it's probably unlikely. The forces are primarily lateral. If you roll over an off-road racing buggy, it's going to barrel roll. So you have significant longitudinal forces as well as lateral. Now the ROPS standards do include longitudinal loads, but perhaps not in the same way that would be necessary for a high-speed vehicle. For that military buggy, we used some FIA-based motorsport requirements, and that satisfied the client once they understood why we hadn't followed the standard that they'd nominated. So all of this is a compromise. Yeah, the usual thing in engineering. You're usually trading one thing off against another. Here you're trading off strength against deflection and trying to get the best possible compromise to meet the standards. Now, I mentioned excavators previously. They now seem to be covered in the standards, but the original problem with testing excavator ROPS and FOPS was the lateral load. Because when you pushed on the structure hard enough laterally to do the testing, the excavator superstructure would rotate. and that wasn't, you just didn't get meaningful results. So I believe there's now some updates to standards that incorporate excavators. Usually in field, people think ROPS and FOPS are ideal for putting lots of other things to it, from lunch boxes to toolboxes to fire extinguishers. I've seen all sorts of things welded onto ROPS and FOPS. And it's a big no-no, because you don't know what you've just done to the performance of that ROPS and FOPS. Just the welding alone can weaken it, particularly if you've done a bad weld job. Putting anything on there like a toolbox that might either stiffen it or cause a point load in a rollover can compromise the structure. And generally speaking, it's a complete no-no to do any modifications to a certified ROPS. But if you're smart, maybe you can get away with it. Well, Mr. Ventrac is certainly getting plenty of free advertising from this series. But the 4500P is yet again a good example. This is a Ventrac ROPS cage. It's a ROPS, it's not a FOPS. And somewhere on it, I know it's got the SAE standard that it complies to. One of the few failings of this tractor is lack of storage space. There are options aftermarket, but they're very expensive and usually come in big boxes from the US. So, being stingy, I decided to do something locally. You should not structurally attach anything to a ROPS cage. The whole thing is designed to yield in a specified and controlled manner. If I was to weld other brackets on here, I would alter that capability and potentially put myself at risk. What I've done technically might be a problem, but I won't know until I roll it over. We've 3D printed a series of clamped brackets, and they're sacrificial. I know that because I've broken a few backing into trees. And in fact, this one here is already broken. Generally, we hang shackles from here. We've got the chains hanging, so we're ready to drag logs. We've got the chainsaw and the felling wedges at hand. And of course, because it's Australia, we've got the cooler bag. So we've pretty much got everything we need to do a clearing job. And it's all close at hand. And by the way, I know it's Australia, but you won't find any beer in the fridge. So it is possible to do things to use your ROPS for other purposes. But I caution you against it. I've got away with it, I think, because these are sacrificial. They're printed in PETG, which is relatively strong and isn't too susceptible to the Australian sun. But they do fail when hit with heavy loads. So I am anticipating, should I roll this machine, and I certainly hope I don't, that if these get hit with a load, they will break off and not adversely impact the performance of the ROPS. ROPS is even an issue for on-highway motor cars. It's something that the OEMs need to consider because cars do roll over. For off-highway, they're almost obligatory. I've even seen, sadly, the results of an aircraft towing tractor that wasn't fitted with a ROPS. The word is the driver had a heart attack as he was coming in to hitch up to the jumbo. The tractor didn't stop, it took out the nose wheel of the jumbo and the aircraft fell on the cabin of the tractor. So even in areas that you think you're safe, you might need to consider ROPS. FOPS, well, FOPS is more about the environment in which the unit is operating. If there's any possibility of things falling on the cabin, perhaps suspended loads in the area, then FOPS is appropriate. As I mentioned earlier, you may need to finagle your way through some standards, pick a bit out of this one, a bit out of that one, if you're not building a conventional standard vehicle that neatly slots into a standard. That's fine to do that. It's responsible to do that because you're trying to make your best possible vehicle. But you'll need to be prepared to justify your solution, particularly to customers who may not have read the standards as much as hopefully you have. You need to consider all the aspects in the standards. They might be a bit scary at first glance, but it's not a hard job to design a ROPS. And to be honest, the testing is sort of fun. Not too many occasions in engineering where you actually get to test things towards destruction and get away with it. So as usual, read the standards, become familiar with the approaches, be sure you've picked the right approach and you've documented why, and then comfortably, confidently move on to the rest of the design process. See you next time.